Okay, so integration by part. The trick is, what do you pick to be u and what do you pick to be dv? So, my first instinct tells me I should at least try this. Okay. But then we get, from here we're going to get an x here. So if you multiply these two, we don't get that. So that tells me maybe I shouldn't pick this. Some other variation. And I'm going to pick n minus 2x. The reason for that is because if I take 2 out, I can make dv equal to tangent squared x, which is equal to secant squared x, right, minus 1. Okay, so I changed to this because that's easy to integrate. This is tangent of x minus x. And this here, of course, we get this, secant square. Okay, so if I call this I, we get the product of these two. Okay, and minus the integral, so n minus 2, get product of all of these guys here. I'm going to change that, the secant squared, into tangent squared x plus 1. Okay, that's what secant squared is equal to. Okay, so let's expand this bracket. Tangent cubed minus x tangent squared x plus tangent x minus x. Okay. Note that if I multiply these two now, I'm going to get back the I. So that definitely tells me we're getting a little bit closer. And this is not a simple reduction formula. So let's multiply those two. And we get tangent nx dx. And okay. So the rest, let's keep it separate for now. So if you multiply these two, you get minus x tangent of n minus 1. Okay, and then multiply this, you get, okay, this is the only term without the x. So I'm going to actually put that separate. I feel like I would have to take care of that separately. So that's tangent of n minus 2 x dx. And this multiplied by this gives you another negative x, right? Negative x tangent of n minus 3x. Okay. So this here is I. So I'm going to bring it to the other side of the equation as plus n minus 2I. This here I'm going to multiply in 2. So we get tangent, you get n minus 1x minus x times by. Okay, I'm purposely doing a little bit slow here so I don't make a mistake. There's a lot to deal with here. Okay, so that's gone. So I can factor out a negative from here to get a plus n minus 2 here. And okay, what I'm also going to do is factor out, okay, x as well as tangent of n minus 3. Okay, then we get, from here we get power of 2x plus 1. Okay, that's nice because this is actually secant. Okay, so this last one here, which was by itself, without the x, this was positive, right? Just want to make sure it was positive. Okay. Okay. So let's compare with where we want to be. So we have this. Okay. If I add this, I get actually n minus 1. So if I divide everything by n minus 1, I get this over this. So this I have already. So how does the rest of the things that I have will simplify to this? Now, n minus 1x, that's right there, right? Okay. So I'm going to write that in blue. So what I don't want to touch, I'm going to write it in blue. So I've taken care of this. I'm just bringing out this out to the front as well. Kind of want to touch those two. Okay, the rest I still have some simplifying to do. Okay, for this one here. So again, integration by parts. I'm gonna let u equal to x and dv equal to tangent n minus 3x secant squared x. du is equal to dx and v. Okay. Now if you do substitution here, if you let, let's say, a equal to tangent, so a is equal to tangent, then this becomes a to the power of n minus 3. So the antiderivative of that, right, is going to be a to the power of n minus 2. So it's going to be tangent of n minus 2x times by the reciprocal. Okay, and this right here is dA, right? That's dA. So it turns out pretty simple. So by integration by parts, so I'm looking at this right now, that can be replaced with, okay, x tangent n minus 2x, okay, over n minus 2, multiply these two, and then integral of this. Okay. Okay. So let me clean this up. So note that these two are same. Okay, that's like terms, and these two are like terms. Okay, so we can do some collection here. So the ones I don't want to touch, I'll just leave it at the front. Okay, so this here, if I multiply by this, right, I'm going to get a minus of integral, right, times it by minus 2. Okay. All right, and then we have writing this down, not doing anything to it. Distribute, you're going to get a plus x. Okay, that cancels out. Nice. All right, hope you're still with me. So these two can be collected. Minus and minus. So we have a factor out the minus. Integral of tangent to tangent. That should be minus 2, right? This is from here. So this is going to be minus tangent n minus 2x dx. So we get n minus 2 plus 1, which is n minus 1. Okay. Okay, so we have n minus 1 I on the other side. So finally I is going to be okay, divide this term by n minus 1. We're going to get just done.